Good day, my wonderful celebrity nation. Today we are working on our lecture 6 of Physics 102, and the topic we're handling today is electric field. And he's no other person than your celebrity teacher, Dr. U.D. Jesus. Now let's look at what we have today. First, let's look at our lecture objectives. By the end of these lectures, these are things I expected you to know. Number one, you should know the definition of electric field. Number two, you should know how line of force and how they operate. Number three, properties of lines of force. And lastly, you should be able to know electric field pattern of different things. Example, point charge, conductors, and all that. These are things I expect you to learn. But before then, let's take a proper revision of our previous lecture. In our previous lecture, we discussed Coulomb's law, if you can remember, and electrostatic force. Now, Coulomb's law states that the force or the electrostatic force between 2 point charges interacting together is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. This is Coulomb's law. If we are bringing it into equation, it gives you the equation of electrostatic force, which says that F is equal to K Q1 Q2 all over R squared. Now, what is electrostatic force? Electrostatic force is the force of interaction between 2 point charges. Note that the force of interaction, that is the force that made two charges interact, either attract themselves or repel themselves. They repel each other when they have the same sign of charge. Example, positive, positive. At that moment, we'll say they are like charges. Why they attract each other when they have opposite signs. Example, positive, negative. And we call that unlike charges. Then we treated a lot of calculations on these two things. If you want to have that lecture, I think there are two lectures that treated this very well. The first was lecture 5, Coulomb's law 1, then Coulomb's law 2. Try and pick up those lectures from our channel and go through them. Now let's go into the lecture of today. Electric field. The first thing anybody will ask is, what is this electric field? If you say electric field, what is that? It's simply a region around a charged object which electric forces can influence other charged particles. Example, if I have a charged object somewhere seated, now how does it influence other charges around it? Let me use something you can see. Something you can see, yes, our daily things down here. For example, if I have a magnet, I don't need to pick a pin and drop it on the magnet before I feel the force of the magnet. But there is a particular region that once I enter it, the pin will be attracted to the magnet. Now, if I bring another magnet around, there is a particular region you can get to, and it will attract it. At that time now, we'll say that this is the field of this magnet. That one is called magnetic field. Now, I'm just using it to explain because this is what you can see. But let's go into charge now. Exactly the same way that if I keep a charge and there are other charges around, at what range or region can they come into and now feel the influence of this particular charge? That range or the region in which these other charges can feel the influence of the present charge is what we call electric field. So, some people can tell you that electric field is a region where other charges feel the influence or influential force of a charge. So when you say, for example, let me use myself as an example, assuming Dr. UD Jesus is a charge and there are other charges around. Now, when you say electric field of Dr. UD Jesus, this simply means within that region where other charges can feel my force. That is all. That is the meaning of electric field. It's not abstract. It's not a rocket science either. It's just normal that anybody can understand. Now, the second thing we should know is, how is electric field being created? Electric field is created by attraction and repulsion of electric charges. What does that mean? Electric field is as a result of interaction of charges. If there are no interaction of charges, there will be no field. Yes. If charges are not interacting, if they are not either repelling or attracting, then there is no field. Because there must be a charge and another charge to feel the influence before you can say, okay, that's field. That is field occurring. So electric field is being produced by the interaction of charges. And what are these interactions? Attraction and repulsion. That is how it's produced. Then it is a vector quantity. Electric field is a vector quantity because it has direction. What does that mean? It's either attractive or repulsive. So it's either going to a particular direction you're seeing it, or is going to another as in opposite direction, but it has direction. So electric field is a vector quantity. And the unit of electric field is volt per meter. We'll explain why as we move on. A unit of electric field is volt per meter. Now, this is the first thing you need to know about electric field. So, for example, in examination, they ask you, what is electric field? I want you to put this down. Tell them the definition of electric field, how it's being produced, what it is, either a vector or a scalar, which is a vector, and then the unit of electric field. You've done justice to that question. The next thing we want to look at, electric field intensity. This simply means the magnitude or size or strength. When you say intensity, we are talking about how the size, the magnitude, how is it, how is the size, how do you, as in, you can imagine like quantifying it. So when we say electric field intensity, this is the magnitude or strength of the electric field. If the electric field, the strength is low, we'll say that the intensity is low. But if the strength is high, we'll say that the intensity is high. So electric field intensity is simply the magnitude or strength of the electric field. It is the ratio of the electric force per unit charge. Now physics is coming in. The first definition, yes, is a definition, is wonderful, but it's always good to make physics what it is. Because the only language or the major language of physics is mathematics. And whatever we define in physics, we'll try to bring out a mathematical definition. So we can say that electric field intensity is the force per unit charge. Is the force per unit charge. So when you say is the force per unit charge, that means, like for example, you can see it there, E equal to force per unit charge. E there is electric field, F is force, while Q is charge. So when you say per in physics, it means divide. So if I say that electric field intensity is the force per unit charge, that means it's force divided by a charge. Now recall Coulomb's law. Coulomb's law says that F equal to K, Q, 1, Q2 all over R squared. But in this equation, I use small letter q and capital letter Q all over R squared. showing you that K is the Coulomb's constant, the small letter q is a test charge, the capital letter Q is another charge feeling the influence, while R is the distance between them. That is Coulomb's law, represented in equation. Now, if E is equal to F over Q, I want to bring Coulomb's law into this, representing my F with KQQ all over R squared. That means my F now being KQQ all over R squared times 1 over Q. The 1 over Q is that divided by Q. Remember, your F is there. Don't get confused. F is there as the whole of electrostatic force, represented by Coulomb's law. We drop it, then times my Q is at the denominator, which means is 1 over Q. That gives me what I have there, E equal to K, capital letter Q all over R squared. Why? Because the small letter q would divide the small letter q up there, and two of them will travel. Two of them will go, leaving E equal to KQ over R squared. And that is the equation of electric field intensity. It is a vector quantity, and it describes the force exerted on a unit positive charge at a given point in space due to an electric field. Now, the unit is Newton per coulomb. How is it Newton per coulomb? I mean electric field intensity. How is it Newton per coulomb? Remember, by definition, mathematical definition, we said electric field intensity is force per unit charge. That is F over Q. F there has the SI unit as Newton. Per means divide. Coulomb or charge on there has the unit as coulomb. So we now have Newton being the unit of force divided by coulomb being the unit of charge. And that is how we have the unit as Newton per coulomb. Physics is wonderful. Electric field lines of force. By definition, we said electric field line of force, this is an imaginary line or curve we draw in an electric field such that the tangent to it at any point should be the direction of the electric field straight at that point. This is your definition. And take it down. Bring your note, pin it down, because this is examinable. They may ask you this either in your assessment or your examination. Properties of electric field lines of force. Now let's look at the property, and please pay more attention to this place, because this can come even in your multi-choice questions. They may ask you which of the following is not a property of electric line of force. They may ask. By that moment, if you know it, you know it. If you don't know it, you cannot be able to produce it. So let's look at this. Number one, we'll say that electric line of force originates from positive charge. Either you call it positive charge or you call it positive pole, it originates from the positive charge. And this positive charge acts as source, that is producer. And it terminates at the negative charge, that is the sink, where it falls into. So, any day, anytime, electric line of force, when you are drawing it, must start from the positive charge and end at the negative charge. That means your line of force should be outward from the positive charge and inward on the negative charge. Don't worry, when we start drawing, I will show you what we meant by that. Number two, electric line of force emerges normally from the surface of the charged body. Electric line of force emerges normally from the surface of the charged body. That's number two. Not from a body that is to be charged or a neutral, or no, it's from a charged body and is normal to it. When you say normally here, we mean that is coming from a body that is charged. That is, you are generating it from an original charged body. Number 3, electric line of force contracts longitudinal and expand laterally. You know your longitude and latitude very well, the vertical and the horizontal. So it says that electric line of force contracts. That means it becomes smaller. And longitudinal and expand becomes bigger laterally. Number 4, electric line of force cannot cross or intersect each other. This one is straightforward. They cannot cross each other or intersect each other. That means you cannot be drawing your line of force and one passes through the other one. No. All of them stays single on their own without intersecting each other. Number 5, electric line of force moving in the same direction repel each other, while those moving in opposite direction attract each other. Please, I want you to note this. This is different from conductors carrying current. They are two different things. Because some students now will say, I thought when two conductors carrying current are moving in the same direction. No, that's not what we're saying. We're talking about line of force now. So when electric lines of force are moving in the same direction, they repel each other. But when they are moving in opposite direction, they attract each other. Put this in your head now. Number 6, electric line of force cannot exist inside a conductor. I think we discussed this when we're treating conductors, insulators, and semiconductors. That's lecture 4. Go and look out for that lecture. It was a wonderful lecture. It says that electric line of force cannot exist inside a conductor, but rather at the surface. Electric field pattern. Now, I would like to take you on a gradual lecture on field patterns of different things they may try you on. Your school may ask you about a field pattern of point charges. They may ask you about the field pattern of like charges. They may ask you about the field pattern of unlike point charges. They may also ask you field pattern of two unlike parallel plates. You need to know. If you don't know it, then most questions that will come with the diagram, you might not be able to get it right. Now, the first one is field pattern of point charges. Field pattern of point charges. The two we have here are point charges. And remember what we said in the property of point charges, or property of line of force. We said that it originates from where? Yes, the positive, and terminates at the negative. So if you look at the positive charge here, you will see that your arrow is outward. That was what I meant that time, that your line of force from the positive charge, being the source, should be going out, showing that yes, it's the positive charge that is producing now, that is moving out, is serving as a source. While if you look at the negative charge, you will notice that all of them are going in. Just like your sink, they are moving into the negative charge. So the positive charge serves as a source, generating them, while the negative charge acts as the sink, taking them or receiving them. So no matter the diagram, no matter how complicated it might look, make sure that this particular thing here must be obeyed. You cannot have an inward in positive, no matter what happens. So whenever you look at any diagram in your options in examination, all those options that have positive going inside, they are wrong. And any option that has negative moving outside, they are wrong, no matter how the diagram is. So this one now is the field pattern of point charges. So I'm discussing them one by one. So look at the positive is outward, and look at the negative is inward. And it remains that way. It cannot change. Now we'll go to the next one. This one is field pattern of like charges. Like charges. What are like charges? Charges of same sign. They have the same charge sign. Positive, positive, or negative, negative. Now let's look at positive. This positive produces, you can see it is going out, and the other positive is also producing, so it's going out. So nobody is receiving what they are producing. What do you see? Both of them will now be switching over and repelling each other because no one can receive it. Now, at the negative terminal, look carefully, please. I want you to monitor carefully what is happening here. At the negative terminal, what do you see? This is negative, negative. Both of them are receivers. There is no producer. So, all of them are going inside. There is nothing there that is going outside. And because there is no producer, there is no connection with another charge. They are just on their own now. Whatever they are receiving is coming from elsewhere, not these two here. So when you have like charges, this is exactly the pattern you will see. Now, what is the difference? If you see positive, positive, you can see all the arrows are going out. If you see negative, negative, you can see all the arrows are going in. But the pattern is the same. And why is it the same? In these two systems, what is happening here is repulsion. There is no attraction here. I like the smile on your face. I can see it from here. Now let's look at field pattern of unlike point charges. Unlike in the sense that now they are opposite sign. You can see this one here, we have positive and we have negative. Who generates? The positive. Who receives? The negative. Now both of them are together. The producer is there and the eater is there. The person that likes eating what you're producing is there. So once you produce, he receives. And what do you see? Attraction will occur. So immediately the positive charge produces the line of force. What happens? The line of force moves into the negative charge. And this is what you have. And it keeps on like this. It keeps on producing and it keeps on receiving. And this causes what? Attraction. You can see it's different from the first one. Here we'll have two producers on the positive, positive. Nobody is receiving. And on the negative, negative, we'll have two receivers. Nobody is producing. But this one now, what do you see? The producer is there. The receiver is there. So as you are producing, the receiver is also receiving. And this is the pattern you will see. And we'll now look at this one, field pattern of two unlike parallel plates. The positive is a producer, wherever it is. Remember what I told you when I was discussing the 2 points charges, their line of force. There is nothing on earth that will make your line of force to be received by the positive. No, it must go out from the positive and it must terminate at the negative. So if you look at the diagram we have here, this is a bar, like an iron bar. Both of them now are iron bars. This one is positively charged and this one is negatively charged. Both of them are unlike parallel charges now. What do you see? The positive bar will produce and the negative bar will do what? Receive. And this is what we'll have. What if what we have here is positive, positive? What do you see? There will be nobody receiving. So it will now look like where we'll have like charges. Both of them will be repelling each other. If it's negative, negative, they will also repel each other. But now what we'll have here is positive, negative. What do you see? An attraction will occur. A very strong bond attraction will occur. Lecture review. I know that you've been able to learn the definition of, I know that you've been able to learn the definition of electric field, the line of force, most especially its properties, then electric field pattern. Please take this electric field pattern seriously. There is no way you will write an exam in Physics 102 or Electricity and Magnetism of any level and you will not discuss or write something on electric field pattern. Maybe we can take you on a brief summary. Definition of electric field was said is a region in which a particular charge is able to express its force to be influenced by other charges around, or is a region in which other charges feel the force of a particular charge. Now, I used myself as an example that if I happen to be a charge, Dr. UD Jesus is a charge, my field now, electric field as a result of me, is within or around me where other charges can feel my force. There is a range you will get to. You can no longer feel that electrostatic force. But once you enter that range where my force is still being felt, we said that you are within my electric field. Then for line of force, we've discussed your line of force and their properties. The major one you should know on the properties is that it must originate from the positive charge and terminates at the negative charge. Very important. And no two lines of force cross or intersect each other. Note these two because it's the regular they always ask during your examination. Then electric field pattern, we said when they are point charges, like here, you can see is originating from positive, while the negative is terminating or receiving there. Now, for two like charges, positive, positive, both are producing, negative, negative, both are receiving. So, what do we have here? Repulsion. Like unlike charges, like this one we have here, unlike charges, positive and negative, the positive is producing and the negative is receiving. So what do we have here? Attraction. Then for bars, this positive, this is negative, two of them will also attract. So we are through with our lecture review. If there is anything you still find a problem with this particular topic, electric field, feel free to share that at the comment section and I wouldn't hesitate to reply you once you drop that message. Don't forget to touch the subscribe button. Now, thank you for listening. Our next lecture will be on electric field intensity. Remember, today we just touch it as part of the course. By our next class, we'll treat it as a full course, electric field intensity, doing all calculations related to it. For now, thank you and have a wonderful day. And don't forget to click the subscribe button and make sure you drop your comment. Make sure you drop your feedback at the comment section. Thank you. See you in our next class.